This part of the program is another panel that we're going to be having discussions about, and this is about what SCU is doing so that we can inform you. Part of our panel happens to be three of our board members. We have Robert Powell sitting next to me here to my right. Robert is one of the founding members of SCU, like I am, I mentioned. But Robert's been with us for a long time, and prior to that, he was actually the director of research for MUFON for many years. I was the director of strategic projects and also in other roles, and Robert and I got to know each other early on, and we really made it all, hit it pretty well, and then we ended up getting into the Aguadilla case together and went on from there, and we decided that, hey, we're going to form an organization called SCU. And so that leads into where we are today and primarily why you're here. So anyway, I'd like to get into that panel with you. And the idea, and we also have Larry Hancock with us, by the way, who is going to be attending virtually. He is another one of our board members and will be talking to us about these different projects we're working on. But we're going to start it off with Peter Reali. Peter came to us and basically is the director of our research efforts that we're doing. And he's been handling the various projects that we've got going on and managing those for us. So we're going to have Peter give like an overview of all the different projects we're working on. And then what we're going to do is hone down into two of those projects with you. The first project is going to be probably talking with Robert and talking about a thing called the Characterization Study that we have, followed by, then we're going to get into, with Larry Hancock, talking about nuclear intentions. We're looking at nuke cases over a period of time and try to see if we can determine any kind of intentions from their behaviors and how they were reported. So that's the gist of the program for the rest of the evening. I'm going to basically start it off with Peter giving a presentation here, opening presentation. And Peter, would you mind telling us what you have in terms of your presentation you can share with us?
Okay, I'm going to just get up and talk a little bit. Well, I have the unenviable position of trying to wake everybody up after having dinner. So, you know, I'll try and make it as interesting as I can. But my name's, maybe you could go to the next slide. Okay, next. Okay. Yeah, I've already been introduced. My name is Peter Reali, and I'll talk a little bit. Today what I'm going to do is first, you know, talk about our project development, what we do in the SCU to develop projects. And the project development is kind of like the engine room of the SCU. You know, it's like it's not, you know, that visible. You know, we have a public. Can anybody hear me? Is it? Oh, can nobody can hear me? Or?
We can hear you.
Okay. Not in back? They're not hearing in back, I guess. Oh, okay. Is there a problem? I mean, anyhow, okay. You know, I want to talk about how we develop projects, and you know, it's not the visible part of the SCU, but it's an important part because, you know, what is our main product is, you know, doing research. And so I want to talk about how we do it. There's a process we have, and it's kind of a mystery to a lot of people because we don't talk a lot about it, but I'll go into that a little bit today. And the next thing I'll talk about is, you know, what are the projects we have? You know, we have a few projects, not a lot of them, but, you know, they are going on right now. And then finally, you know, we would like to have, I would like to, for people who'd like to get involved in our research, how you can do it, you know, and we'd like to recruit people, you know, that are interested, you know, outside the SCU and in the SCU, and, you know, could join the SCU and do research. And, you know, we have a lot of ideas about things that we really can't go ahead with because we just don't have the people to do it. So I'll go ahead. So next slide. Okay, this is a, I wrote this. When I joined the SCU, I joined probably about, you know, 4 or 5 years ago, and it had already they'd already done the Aquadia project, but I looked online. I was kind of interested. I retired. Okay, about me. I'm an electrical engineer, a master's degree from UC Berkeley. I worked in Silicon Valley for like 25 years or more, you know, and I retired. And most of the companies there have a process, you know, of development for projects, you know, all kinds of projects. And you know, when I started, the SCU was probably, I don't know, 10 people maybe, and now we're 190. And so at the time I thought, you know, if we grow, what if we grow to 1,000 or 5,000 people? We do things informally now, and we skip, you know, I show 5 steps, you know, to developing a process. But that just won't be, you know, if we have 50 projects, you just can't keep doing things informally. You're going to have a process. So this is a kind of a forward-looking development cycle. I'll talk about the individual stages. And but it's so that we can grow, you know, sometime in the future, we may get people who want to invest in us, like, you know, some outside organization or something might want to have us develop something or go in something. So we, you know, they're not going to look at us and unless we're professional in how we deal with things. So, you know, currently we only do the first. I'll go to the next slide. It has the details of each one of these. So there's 5 steps, you know, to a project development. Currently we do like the first 2 and the last. You know, it really don't. And I'll talk about, you know, how that goes. Usually there's, you know, people have an idea, you know, or there's usually 2 things. We have some kind of a development idea of research we want to do. The other thing is we may get like what happened in the Aquadia or the Nimitz case, we actually got data to be able to analyze, you know, a particular event. And I can't speak for the Aquadia, but I can speak that Robert and I worked about 1.5 years on the Nimitz report. And that's the kind of time it takes. It takes, you know, to go in and do we call it forensic analysis. So, you know, it's not like regular science research, like you're going over some kind of hypothesis or some kind of physical theory. You're taking an event and trying to understand, did it really happen? How can we validate this event? And so you go through all kinds of aspects of it. You cover everything to prove that it's anomalous. You know, what we mean by that is you cannot explain it by you know, any kind of a normal misidentified object. It's something that's unique and worthy of you know, future research. You know, we don't know what UAPs are. I don't think they're one thing, you know, but we know what they're not. And that's kind of the tack that we took. Now, there's been big advances in us. I mean, I don't think we ever expected that the DNI report would come out, or you know, that you know, the government would actually say these things exist. I think when we started, we were trying to prove that they were real. So now we have legs to stand on, and we can do more research because no one can deny these things aren't real anymore. Like Ryan talked about, you know, Ryan Graves. And you know, there's indirectly a little bit, the AIA is going to be get involved with it. I mean, they have 30,000 people in it, I think, something like that. Huge organization, lots of scientific basis, but there's still a lot of skepticism, you know. And so our job is to kind of like overcome that and move this thing forward. So the way it works is, you know, somebody has an idea either for some kind of a analysis or some kind of event that took place, and I'm a member of the board as well as you know, the development director, and something would come to us, and we have to figure out, is it worthy of going ahead into a project? Because, you know, we have limited resources. We're all volunteer, and if you look at us, a lot of them are kind of old. You know, they're retired, so they have time. We'd like to get younger people involved, you know, but I know it's tough because you have jobs, you've got families and all those kind of things, and putting the time in on it is tough. But still, it's very exciting. If you have a passion for this, you'll find the energy to do it, you know. So, you know, once we have a kickoff meeting, we decide to go ahead with it. You know, we go to the next stage, and that's a specification meeting. And so you write up, you know, there will be a lead. There has to be some kind of a lead for the person who's responsible for the project. And then, you know, some other people to help him out. Usually it's not one individual. It's just too much for any one individual to do. And so you write up some kind of a specification, you know, with what your objectives are. a project should have an objective. It shouldn't just be open-ended and everything, because they'll kind of go nowhere. It has some kind of an objective to prove something. And, disproving something is just as valuable as proving it. That's knowledge. If you find out something really isn't true, you've made advances as well. It's hard for people to take, but that's also positive progress. So, you find something, so you lay out, some kind of a early schedule. Do you have, so the board, can look at it and see, is there something we can help on this? The board takes a position of monitoring it, throughout the development cycle, so that, it can keep it on schedule and help out. Sometimes you run into problems and you need, financing or extra staffing. We can help find people, those kind of things. So then the third stage is something that runs, usually there's a project manager. And this sort of is outside, the board, and multiple, over a period of a year, or, we'd like the projects to, we'd like a project not to have to last more than a year or 2 years. And I mean, beyond 2 years, it gets kind of dicey. But, they have regular meetings, and then they report to me status reports, how these are going once a month, and I report to the board. And if there's any issues with things, we try to find a way to help the thing, progress. And that's how it goes until we go to a point where, usually there's two kinds of projects that we do right now. One is like would be some kind of like a white paper or a project report of some kind, like something like the Nimitz report. We would write a rather extensive, I think the Nimitz report is like 170 pages or something, and it has all kinds of analysis in there to show what we did. But it could also be a white paper, which would focus on, say, some kind of technology, have to do with maybe developing a certain kind of a camera, or something to do with propulsion of what we think might be a UAP. And it then has to go to like a peer review. We peer review all of our research. And, usually there's 3 peer reviewers, and Paul Kingsbury, who's one of our members of the board, he's responsible for that and doing a really good job. I have a project in there I'll talk about in a little while that's in the second phase of peer review. And one of the, so we go to that. When it passes peer review, it becomes an official SCU document or a research item, and it goes on our website, and we will back it up, as that we have done the research, and this is a valid, this is a valid research effort we did. And we're hoping with a couple of our projects to actually be able to get them published in, reasonable journals, scientific journals. We've had a lot of problem with some of our previous stuff because of the stigma associated with UAPs. They don't even listen to you. You can have valid research, and you can't publish it because they just say, well, we don't cover that stuff. Now that's, I think, going to change. And one of the type of projects that we're not doing is some kind of a hardware project or a software project that would develop something. So there's like if you did a hardware project, let's say somebody came to us and they wanted to develop a some kind of well, kind of like what UAPX is doing, some kind of a station, that remote station that would be out there. It is going to have to, have a beta trial. You can't just release something and, you have to have a beta trial, make sure it works right, and then for the same thing, it could be, when it passes that and works, we can then release it, as official. So we're not doing that now, but it's there. We have the process for future if that kind of stuff happens. We could also go after government grants. We may have an idea, something, and get a government grant. I've actually done that in the past. Where it's possible to get, if you have something interesting, like, certainly like drones are a big issue right now. And, the barrier between drones and UAPs is pretty fuzzy, and I'll talk a little bit about that later. But we finally go to a project release, and then we have an official, either a piece of hardware or a, or a piece of research that we've done. So next slide. Yeah. Oh, okay. Yeah. It kind of look the same. All right, so these are the projects we currently have active. And as you know, Rich has already talked about, he's stole a little of my fire here. But there's two projects that will be talked about in detail. The first one is, well, I'm jumping over exactly the order that he had, but it's the Intentions Project. And what this is it, you know, as you can see, it has quite a few members. It has, the lead is Larry, and it has Robert Peterson, Ian Porritt, Mike Hoffman, Larry Cates, and two anonymous members. Let me talk about anonymity. Some people, it is still hazardous for them to say they're associated with UAP research. So they want to remain anonymous, and you know, so we honor that and whatever. But it's pretty well staffed, and it's fairly well along. They're basically doing statistical analysis of databases, which I'll talk about where they got that, you know, to see if there's a statistical correlation between nuclear sites and UAPs. You know, were there more sightings, you know, at nuclear sites than there were at, you know, ordinary locations? So the intention is there some kind of intention to UAPs, and prove it statistically. And so they're doing a lot of work. It's actually fairly mathematical. It's statistical analysis that they're doing, and he'll go into that in detail, so it's really pretty good. The second one is Robert Powell, and also, you know, he has some people working with him. It's called the Characterization Project. And this I won't steal his fire, but I mean, it's basically they have, you know, historically there's been these databases like, you know, Blue Book, NICAP, QFOS, and MUFON. And they have these big databases, but the quality of the data collected, you know, there were no standards about how to do this. So they're using, you know, various, they take the databases and filter them, you know, using maybe AI, like NLP, natural linguistic processing, or you know, various techniques to go after better, you know, kind of discard the poorer ones that have less data in it. It's not like they're changing anything, but just you know, like take the sites that have like multiple witnesses. That's more reliable. Or take the sites that have actually some angular size of the object. You know, something that you can't just say I saw a UAP. Well, it's not very valuable. You know, great, you saw it. Actually, those can be valuable, like to show that a particular area at a certain time had a lot of, you know, a lot of UAP events. But they're not going to help you analyze what the UAP was, or, you know, get down to the bottom of the physics of it or anything like that. But, you know, they're not totally valuable. But they're trying to get stuff that's more valuable. The angular size, sufficient lighting, good data. So they end up with a better database that's a combination of all those. And actually, that database was fed back to Larry Hancock and the Intentions Project, and they've gone ahead and filtered that even more to get their stuff. So that's how, you know, these two projects are interacting. The next one is by Dr. Tim Oliver, rather. It's called the Propulsion Project, and it's been going on about a year. And when it started, it was a much more comprehensive project. But it's so comprehensive that we decided to break it down recently into like 4 separate projects, or actually 5 projects. And what it is, you know, the first one is using computational fluid dynamics. And it's you know, UAPs fly along and they have certain characteristics. And, you know, they do a lot of things that, like, they don't seem to, well, a lot of them, they don't seem to make any noise, interfere with the atmosphere. You know, they can levitate. You know, they can move at very fast speeds. You know, seem to turn at right angles, all those kind of things. So the first idea was to think about how could they do that? And one of the theories is that there's some kind of a force field around the object that repels the atmosphere around it. They don't try and, in this particular part of the aspect, they don't try and figure out what that force field is. They assume it exists. So what would be the effects that you would see if you had this force field around it, so traveling through the atmosphere? Would that reproduce? Would you still not see any sonic booms or heat or any of those kind of things? Because it's not really well known. I mean, you can say, oh, it shouldn't happen, but fluid dynamics is a very complicated subject, and until you do, there's open source, there's a thing called open foam. It's an open source computational fluid dynamics program, and he's using that to simulate these. And so he will write a report, a much smaller report, that goes into the results of all these, and these will be released and probably can be submitted to a journal somewhere, because it's really not about it's not only just about UAPs. It's valid for airplanes and anything, space travel, all that kind of stuff in the future. So the next one is, propulsion mechanism. And we have Dr. Detlef Hoyer, and he's an expert on a five-dimensional relativity theory. It's called Kaluza theory. And Kaluza, I'm not an expert on this. I'm kind of taking, from what I know. But it's an old theory. It goes back to 1921. It was sort of it was found that, adding an extra dimension to universal theory, Einstein's theory of relativity, you could actually combine gravitation and electromagnetic force. And when you do this, you get, it produces new kinds of forces and lifts that would allow an object to travel, to be able to levitate, travel at very high velocities, and do a lot of things. So he's working on that theory, which will become a separate research project. And that theory will, whatever the results are, can be published in a journal. And the idea is that at the end of this, we'll have an umbrella report that can call these will be released research efforts, and they can just be referred to, rather than have to put it all in one giant, 250-page report. It'll be much smaller, but much more tighter and solid, I think, in the way. So next slide. So another one, these are two more in a formative stage. So we're looking for people actually to get involved in this. We don't have people right now to actually, we have some staffing, but we could use some people who might be interested. One is a propulsion mechanism based on magnetohydrodynamics. And this has been proposed for many years as a way of these things might propel themselves, the UAPs. They basically ionize the atmosphere, and they use a magnetic field with a Lorentz force to propel themselves forward. And actually, the Japanese actually built a speedboat based on this. And it actually worked. It could go about 17 knots, but it just didn't turn out to be any better. It was actually less efficient than a regular gas engine. But it actually works, And what might be is, an advanced civilization or something may have superconductivity. They may have, power sources that are much smaller. It would make this thing work. So the idea is then to study this and, give some thought about how this might work. And so I'm kind of leaving out the overall, these things have signatures. We've talked about signatures. They can levitate, they can do right angle turns, they can do all these kind of things. The idea is that these different kinds of propulsion mechanisms will have different signatures associated with them. The idea is any kind of a signature, there'd be kind of a Venn diagram, right? The ones that most overlap the different kind of signatures might very well be the technology they're using. And so that's an advancement, or at least something that can be researched more. Another one is a favorite of mine is general relativity. This is just simple four-dimensional gravitation. And to my mind, this one, there's been a lot of work on this that explains a lot of the capability of UAPs. Like the ability to accelerate at fantastic speeds. Well, there's Kaluza-Klein, not Kaluza-Klein. There's Albuquerque, I'm always probably pronouncing it, but by warping space, you can actually, you're not really accelerating. You're actually traveling in a warp bubble and extend, you shorten the space in front of you and extend it behind you. And it has all kinds of signatures that it produces. but you actually overcome this, the killing people with these accelerations. The other thing is, it could levitate. It can, do a lot of the things that explain a lot of the, the things we see that we can't explain. And we're looking for, there's probably a lot of people out there might be interested in this, but they're going to have some kind of background in relativity, so they probably have some, pretty good physics background. The final one is radar. Now, radar has nothing to do with propulsion, but one of the, we have, Alan DiCenzo and one anonymous person that are experts in radar. And now we're not going to, this could be added to a suite, of detection mechanisms that would go in the field. And now we can't transmit radar. The FCC doesn't like it for people to be transmitting radar signals, unless they're licensed to do that. So, for very specific reasons, and because it interferes with, all kinds of other stuff. So they're looking into passive radar. What passive radar is, you basically listen, and when an object goes through the atmosphere, locally where you are, there's radio stations, there's GPS, there's cell towers. That will interfere, that'll cause echoes. And you can actually detect these objects. The first presentation today with the university, a German university, actually one of the students was doing passive radar and actually could detect things. I just noticed that when it was there. So this is a this is a tricky business, but it would have certain signatures that would be interesting. So there's a research paper that can go on there. So that would comprise those projects that we're working on, and we're looking for people to help out on it. The next one is go back. The next one is a sound project, and it's headed by Dr. David Moore, and it's been a little slow going because of COVID. There's been some problems with family members, and we're hoping to get back on track. Now that COVID is, hopefully over, or at least it's minimized, that we can get back on track with that. But it's developing sound detection systems, optimal detection systems that we could use for field, for detecting UAPs and whatever kind of sound signatures they have. And the final one is, I'm the head of this thing, and it's called, I tried to change the name. It's called the Rubber Duck, and I get a lot of people like to call it Rubber Ducky, so I gave up. I'm just going to be called Rubber Duck, and it's an interesting. We got this video, and it's a forensic analysis of Homeland Security. There's two movies, and there's about 45 minutes of an object that crossed from Mexico into Arizona. And in the area, and it sort of circles an area. The area is the Buenos Aires National Wildlife Refuge. It's down there. It's about 80 miles from Tucson, and it's a very strange object. It was recorded on infrared, with their it's a military grade, system, and I couldn't have done much analysis without knowing the metadata. Now, one of the problems with these cameras is each manufacturer is a little different, and the metadata is different. So unless you know the definition of what that metadata is, and fortunately we had one of the members of the SCU is David Fouch, and he was a big help. He actually works on these devices, and he was able to get so I could understand what the metadata is. And so I was able to do some analysis, and it's about a 46-page report, so it's not a really short one, but I'm going to release it. It's in the second stage of peer review, and it's been approved by 2 of the peer review people. The third one is he couldn't get on it again until end of June, so I'm hoping by the end of July to be able to release it. And I'm not going to talk a lot about it. You're going to have to wait to the final result because it's just, if we release stuff, people make stories up, and pretty soon the whole thing is, just we might as well not release it. So that is the current projects we have on. So the next slide. So I just want to talk about the membership of the SCU, and Rich sort of covered this earlier, but I wanted to go over it again. We have about 190 plus members and 92 contributing members. And 30% of our contributing members have PhDs in various areas. 54% have advanced degrees. Engineering is the most common, it's 19%, and physics is like, and astronomy is 13%. 32% of our members have military backgrounds, and that's good, you know, for investigations, you know, how to investigate things and go out and find out the validity of stuff. 20% of our members is international. You know, we have people from all over the world, as you can see, you know, from our presentations, and, you know, they're interested in this. It's a universal, you know, universal interest. It's a worldwide phenomenon. And so we have members, you know, from NASA, European Space Agency, Canadian Space Agency, or, you know, backgrounds from defense and high-tech technology, aerospace, and professors from all various universities. So, okay, so why did I go over this? So next slide, please. We need help. And, you know, if you're interested, you know, we don't just do, you know, most of what I've described is physics, some kind of physics or engineering, but, and we need help on those, as you can see. If you're interested, you know, you can apply. I'm going to tell you how to, you know, how to apply. And, but we also want other projects. You know, there's, you know, in psychology and sociology and those kind of things. I thought the Alexander Wendt presentation today was very interesting, and you know, that kind of research I think would be very valuable for the SCU. I also been thinking about another project that I've been collecting data on, and that is drones. I don't have time for this, but there's tons of drone incursions in the United States over nuclear sites, over power plants, you know, that been reported by Homeland Security and some of the other things. And of course, they have a checkoff list, you know, when it goes down and, you know, it says, what can it be? Well, it's an airplane, it's, you know, it's a bird, you know, or something like that. And then if nothing else, it's a drone. But these things, and a lot of them are drones, but a lot of them have, I've studied drones a little bit, and some of these things have capabilities that are way beyond any kind of a normal drone. So there's meat to be dug out there. So the first step would be to collect and make a database on this. And I know there's some people within the SCU who have kind of done this already, but I'm trying to like to recruit them into a more focused project. And so I'm, you know, if you're interested, let me know. So we want to, you know, suggest new projects, leverage our many talented people. We have all these talented people. Some of them may want to help. You know, you may want to get involved, but just don't know how. So I'm trying to tell how to do it. And we want to expand our research efforts. So if you want to contribute, you can go to our website, and it says www.explore.org/projects. There's a page there that tells you, you know, how to get in contact with me. I can put you in contact with these other projects, or you can suggest a project, and we'll look at it, and it may start a new project. So, you know, I'll have some cards. You can, if you're interested, come up, talk to me. I'm the guy to talk to. And, you know, on this particular page, it describes how to contact the project director, that's me, and to find out what projects we might want to assist with, suggest new projects, and there's also some documents there that took, what is a valid project? And I kind of went into that. You know, it should be targeted towards some objective. You know, it shouldn't just be, you know, open-ended. And the technical requirements for a project, and it also has the development. You know, it's about this. In the beginning, I talked about this 5 stages. There's actually, it's about a 6-page document. It goes into real detail about it, how to run a project. So that's about it. I hope generated some interest, or if you know somebody who's interested in, you know, the UAP research, you know, contact us. And so thank you. Thanks for your interest. And, you know, it's great to see, you know, it's really, it's been really gratifying to me to see how, the SCU has grown, you know, from a handful of people to 190 plus, and I'm thinking that we're going to get really big, as time goes on, and you'll be proud to have been a member in the early stages of it. So thank you. I didn't talk too long.
Okay, next to talk to us is Robert Powell. He's going to be sharing us a deeper dive into that characterization study that he's working on. So without...
All right, thank you, Rich. Let's see. Okay. So Peter and I have a commonality. We both came out of the semiconductor industry. The difference is Peter was a design engineer. I always tried to stay away from design engineers because I handled testing, manufacturing, quality control. I was kind of a jack of all trades. As a matter of fact, I probably have ADD because I'm a jack of all trades in SCU also, so I can't keep my attention focused sometimes. I want to tell you a little bit about the characterization team. I'll start off first with who the team members were. So in addition to myself, there was Larry Hancock, who you will hear from in a little bit, Ian Porritt, who is from New Zealand. Ian also happens to study and has actually found one extrasolar planet, so he's an amateur astronomer. And then also the University of Toronto worked with us. And Ike Okafor was their main lead. He is over their diversity program. And so we had 3 students that worked with us on this project: Robinson Trong, Toby Kamoru, and Laiba Hassan. So we felt it was important to involve universities as much as we can in this. Now, let me do a quick show of hands. How many of you, I want you to raise your hand and keep it up, have seen a star-like object that you could not explain? I'm not saying it was a UAP or from another world, but how many of you have seen a star-like object you could not explain? It doesn't have to be moving. It could be stationary. Okay, so we got a good, okay, keep your hands up. How many of you who saw that object, the object was larger than 1/3 the size of a full moon? Okay, how many hands do we have left? We've got 4 or 5 there. Okay, so of the remaining ones of you, how many saw the object during the daytime? Okay, so we still have about 3. How many of you, was there a full report written on your experience? We still have 2. So that shows you we started off with a lot and we were down to 2. So this is basically what we did in the characterization project, because we wanted to characterize the features of UAPs. So anyone who just saw a dot in the sky, it didn't matter how it moved, those were eliminated. Let me ask one more question of those last 3 or 4, because there's one other criteria we had. How many of you, raise your hands again, the 3 or 4 that were left. How many of you, were there other witnesses? So we still have about 3 or 4. Okay, so this is what we did in this case. We took the Project Blue Book database, which is, I think, something like 15,000 cases or so. Now, we didn't go through every single case, but there are other databases where other people have done that to a certain extent, so we were able to cull through it rapidly. But it still took us a year to do this. So what we did is what I just explained to all of you. We looked for multiple witnesses. We looked for objects that were at least 0.15 degrees in size. That's basically 1/3 the size of the full moon. That means that witness should be able to identify features on the object. Did it have wings? Did it have a window? Those type of features. So we took all of those cases, and that basically gave us 300 some odd cases out of tens of thousands that we would have started with. These are the cases that we looked at. Project Blue Book, NICAP, CUFOS, and MUFON databases. So this was a lot of work over the course of about a year. Now, we haven't completed the project yet, so I'm just going to show you some preliminary data. We plan on writing some papers based on the work we did, but I'll just give you a kind of feel for some of the things that came out of it. And remember, what we're trying to do is we're trying to get cases where it should be clear-cut that the individual saw something, because we have more than one witness, it's in the daytime, and the object makes up a fairly large size of the sky so that you can see features. So if you look at this particular graph right here, witness estimate of object size by decade observed. So of these 300 cases from the 1945 era up to modern era, if you look at the orange there, just kind of focus on the orange, which is basically the, I have to almost take my glasses off to see small print. That's one thing I'm blessed with. As I got older, I can see small print. So if you look at the orange, as you notice that slowly is decreasing over time, which is indicating that the objects are getting larger, because if you look at the bluer type colors, right, which is greater than 500 feet and 100 to 500, what that tells you is, for whatever reason, that over the decades, the objects that were reported within the last 20 to 25 years, they're much larger than the objects that were reported in the 1940s, 50s, and 60s. Now, you might ask why, and we would just be guessing at that point, right? We could come up with some theories. One theory might be triangles came into play in the 1970s and 1980s, and as a general rule, the triangular size objects are much larger than disc size objects, which were predominant earlier in the decades. This is about speed. So if you look at the dark blues, medium blue and dark blue, just kind of focus on those, and you can see how those increase over time. If you go from left to right, you're seeing that your dark blue and medium blue peaks are going up. This indicates that the general speed that the witness felt the object was moving at has been going up over time. And if you look at your yellows and oranges, that's slower moving objects. You can see those are decreasing over time. This one is a very interesting one. So let's look at it for a little bit. The blue are non-triangles. In other words, we took all of your UAP descriptions, and in one bucket we put all the triangles. The other bucket, everything that's not a triangle. And we're looking at it across the hour of the day. On the left-hand side where you see 00, 01, 02, that's the hour of the day. So right there you're at midnight, moving forward, 1 a.m., 2 a.m., etc., till you get to the far right hand, and you're looking at 2300 hours, which is 11 p.m. at night. So there's two things I want to point out on this graph. The first one, I think you may have heard a speaker earlier on talk about the law of the times. This is something that's been noticed by other researchers over the last 30 to 40 years. And that is that if you look at the hour of the day, there's always this big hump that you see where you see the red and the blue, right? It's around 8, 9, 10 p.m. at night. There's the reason for that, and I think most people would agree with this reason, is that's because that's when most people get home from work, they go outside, they look at the sky. And so you have your big peak at that time of day. And that doesn't mean UAPs are real or they're not real. It means that unless someone is outside looking for them, you're not going to see them. So by definition, you're going to have a lot more people looking at the sky in that time of day. Now, the strange one, though, is the one on the far left, and that is where you see the little peaks that pop up at 2 a.m. and 3 a.m. in the morning. I have not heard a good explanation for why there should suddenly be an increase in number of cases reported at 2 a.m. and 3 a.m. in the morning. Now, some people have told me, well, that's when people get home from late night drinks, and so it's 2 or 3 in the morning when they finally make it home and look up in the sky. I think that's an interesting one, but I don't think I quite buy that one. But that's been seen before. This database is not the only database that has shown that particular feature. The other one, though, that's here is one I've never seen before, and that is the triangles. So first, just focus on the blue. Those are non-triangles. See how all across the 24-hour clock, you've got blue at varying levels, right? But if you look at the red, that's your triangles. Notice how, for whatever reason, people are not reporting triangles during the daytime. It's like they don't show up till dusk.
Can't test projects during the day.
Could be. Now, that doesn't mean no one has ever seen a triangle during the day, right? What this means is that we are looking for people who have seen an object close enough that they can definitely recognize it, right? And it's based on the 300 cases that we zeroed in on based on those features I talked to you about, which was the size in the sky, the multiple witnesses, daytime when possible, and if it was at nighttime, there has to be a light that illuminates it in some way so that you can see the object. So I thought that was one of the most interesting of that. I'm going to end that. So those are just some of the things that, that we were looking at. One thing I can tell you in general on this, and this is true of this database we've created of 300 plus cases. It's also true of large databases I've looked at. And what this truth is that I have never seen a pattern across time on UAPs. And I've looked in the semiconductor field, I did this all the time. I looked for patterns in silicon wafer chips. I looked for how can we make them faster? How can we make our yield improve? And we looked at thousands of parameters to look for patterns like that. In the case of UAPs, I've never found a pattern that could tell me, okay, for example, from 1940 to the modern era, at certain times of day, all of a sudden you would see UAPs, or a certain month of the year, or a certain day of the year, or they came in a particular wave patterns. There was never a pattern that I could find. Long term. Short term, you can find patterns. If you look at specific short time frames, by short, I mean 1 day to 2 weeks, maybe 3 weeks, in specific geographic areas, you can see patterns where an object, similar objects are reported by people over and over across that short time window. But then you don't see it anymore. So it's not like you can say, okay, that's going to happen again. A good example is Levelland, Texas area in the late 1950s. There were multiple reports that happened there, and over the days there were reports in White Sands, New Mexico, which is not that far from Levelland, and they were the same type of object. So those type of patterns we can find, but we can't find the longer-term historical patterns that you would hope to be able to find. Now, that doesn't mean they're not there. It just means so far I've not been successful in finding them. So that's kind of a summary of our characterization project. When we get to questions and answers later on, I can answer anything anyone brings up. And I think next will be Larry. And so he will talk to you about the Intentions Project.
If I can, before Larry comes on, I'd like to share a little story with you. I was at the Dayton Engineers Club in the late 60s. This is when Project Blue Book was still open. And I heard Dr. Jalen Hynek at the time, who was still a consultant with the project. And he delivered a presentation. And one of the things that they did with the UFO cat, they did a similar analysis. And what they found out was the same, very similar to you. They found out that between the periods of 9 to 10 o'clock, 11 o'clock, of course, people were reporting. And then they also found that the second period was around actually 4 o'clock, 5 o'clock in the morning, and they figured that that was due to a shift change. Now you got people coming home for late night shifts and are actually seeing, but theirs was, that's what they had found. And it's interesting that yours came up with like 12, 1, 2 in the early time period.
2 and 3 a.m., yeah.
And another thing that they found out was that, if you think about it, there was always the question of whether or not UFOs are a summer craze. In the Northern Hemisphere, that they found out that generally in the July month, it was the most peak month for reports or something of that nature. Guess when it was in the Southern Hemisphere when they were having their winter? It was July. So it was not a summer craze. It was actually in July around the globe. It was not just winter. The dead of winter, they're experiencing those sightings. So that was interesting in the sense of finding out those patterns from the data. Anyway, I just want to make that point since you had just made that point that was kind of interesting. The next thing we're going to do is talk with Larry Hancock, who's going to talk to us about what the Nuclear Intentions Project is. Larry, are you out there?
I'm here. Everybody can see me? Okay. First of all, I'm happy to be here. I'm happy to talk about the Intentions Project. It has been underway for over 2 years now. So obviously, after that time, it's good to be able to talk about anything that you've actually discovered or learned from your research after 2 years. I'm also happy to follow Robert Powell. Robert and I became very close because while we were doing the characteristics data collection, he and I would spend a couple of hours, 2 or 3 hours on the phone virtually every week for what, Robert, maybe a year or more, thousands of cases. So it certainly gave us a chance to make a personal connection. So I'm happy to follow Robert. And we did, as was mentioned earlier, Peter mentioned, we did lift a lot of the material and concepts from the characteristic study to bring into the Intentions Project. One of the things we did was we also, and Robert didn't talk too much about it, but it's important to say that we have a lot of signature data in these databases that relates to what Josh was talking about earlier. Off the top of my head, I would say if you looked at our spreadsheet, we have at least 10 or more items of signature information. So I just like to point out that the databases we have been building could be used for other things and could actually be used for signature analysis, although that's not what we've done with them up to this point. So if we could put up my PowerPoint. Basically, when Rich invited me to do this, I said, Rich, it's great. I'm excited to do it. If you can give me 2 hours and about 40 slides, I can give everybody a really good view into what we're doing with the Intentions Project. Rich responded by saying, Larry, you're out of your mind. How about if I gave you 20 minutes and 14 slides? And I said, well, of course, no problem. I can do that too. So that's what you're going to be seeing this evening. It will be basically just an overview to try to give you a feel for what we're attempting in the project. I can respond to questions later, but I'll have to stay at a fairly high level. The Intentions Project basically is just what the title says. Our goal was to do a couple of things, to look for anomalies, just as Robert was mentioning. The whole structure of the research depends on looking for and searching for exploring for certain types of anomalies, and then doing pattern analysis, and then taking it a step further using techniques that we derived from strategic intelligence work, which was mentioned earlier during the panel. We modeled or will be modeling much of our final study of practices related to intentions and indication analysis against various scenarios. So we are, even though this is not pure physical science, we're trying to be as objective as and quantifiable and open with the analysis as we can be. So, but ultimately our goal, as with all intention studies, as Josh and Joe would tell you, our goal is to give an estimate of the situation. Basically, is something anomalous going on with UAP activity in a particular domain, area of activity? Is something anomalous going on? And if so, what particular scenarios seem to me most probable? Which means in the end, we have to take all of our pattern work, all of our case studies, and do a ranking against alternative scenarios. And that is down the road. I'll get to that in a minute. But so that's what the Intentions Project is intended to be. It's an ambitious project. Over the last 2-3 years, we have had probably 9 or more people involved in it. Some have dropped out along the way for various reasons, including health. We have 5 very active members at the moment doing database work, analysis and charting, statistical analysis. It's very aggressive and very time consuming, major time commitment. As Peter says, it helps. A couple of our members are retired. A couple of our members are not retired and working and have far more energy than I do, because I think they spend as much time on this as they do working, which means like an 80-hour week. So let's go to the next slide. So what is our approach with the project? Our approach basically is to first off, to look, evaluate data for anomalous patterns of UAP activity over time. Pattern analysis, pattern recognition is our most fundamental technique. Quite honestly, if we had spent 2 years and found no anomalous patterns, we would have reported that. We would report that. As Peter said, negative findings in science are as important as positive findings. So that could have been our conclusion, that we examined all the data, we found no patterns, we found no correlation, nothing unusual is going on, there's no sign of intentions in this domain, the area of activity that we're studying. We have the ability using this technique of strategic intelligence to study multiple domains of interest. Our starting point, as you will see, is very specific, a very concrete area, which has to do with UAP activity at atomic warfare complex installations and aerospace development installations. That's our starting point. However, there are other domains that we can move into to test in the same way. Peter mentioned psychological, sociological. We just happen to pick one particular domain to start with, to some extent because it's a continuation of what the Air Force attempted to do back in the 1940s and 1950s and failed to do because they never really elevated it to the level of strategic intelligence. They kept addressing it on what I call a one-off basis. Let's look at every report, explain it, not explain it, put it in the file, which is not this dissimilar to what the current UFO project appears to be doing, UAP project appears to be doing. That doesn't get you a strategic intelligence analysis. It doesn't give you long-term pattern work. It basically is a way to dispose and file the incidents as you go along. So in any event, let's look at that slide again. Okay, so we're going to restrict this first phase of our study. We're going to tie it down to a couple of domains. And the way we're going to approach it, or we did approach it, was to use baseline levels of UAP activity. We have to have that because we're going to be doing comparisons. And for our baseline levels, our fundamental baseline was over the period of the study, which is 1945 to 1975, is the level of activity that was being reported to the Air Force. Basically, the Blue Book UFO reporting totals for each year. That kind of gave us a baseline for UAP activity. those weren't did not turn out to be what we chose for our actual study, because we backed down and said, no, for the actual study, we're going to take the UAP reports that were investigated and declared to be unidentified. So right off the bat, we tried to establish a quality level differentiation. Even though our baseline is total reports, we're going to study the unidentified object reports that were investigated. And to do that, we took a combination of the Blue Book investigation and a certain series of other investigative reports that you can take from NICAP, from their field investigations, and from in the later period that you can take from documents that have been found by FOIA and disclosed to some really good researchers that relate to the period of 70 to 75 once Blue Book had shut down. But that is an important period as far as atomic installations go, because it involves some major incidents at SAC bases and ICM bases, referred to as the Northern Tier incidents. Okay, back to the slide. So, okay, that's our approach, that's our baseline. So how do we get to the actual study? Well, to actually study and do this in a very controlled basis, we decided we don't just have study sites, we need controls. Any good study needs controls because, yeah, we can compare activity to the baseline, but we need to go a level deeper than that. So we established control sites for every location that we were actually going to study to see if it had anomalous levels of activity. And then finally, we'll translate that to pattern analysis. So we can move on to the next slide. In the initial study, as I said, domains to be examined, the American Atomic Weapons Complex and the American Aerospace Test and Development Complex. Why do we restrict ourselves to this? Basically, it's because we can get a level of detail on what has been released now and what was going on timing-wise with the American complexes that we just can't readily get from other nations. I'm not saying other people couldn't get them, but we chose to start with something where we could get a very discrete level of detail. And our study question is, basic questions, will we find indications of anomalous patterns of UAP activity within those domains during that study period? And if so, what are the correlations? The correlations in level of activity, correlations in timing, correlations to significant events, and we did build a significant event database as well to use for correlation testing. Next slide. Okay, now we're gonna, this gets better. We get away from the word slides and we get into a series of charts done by Ian Porritt, who is our team member who has an awesome ability to analyze data, correlate data, and put it in graphic format, which I would never have been able to imagine by myself. These are the phases of the study that we went through. After we had built our databases, after we had collected data, phase one, we picked a series of study sites at the radioactive materials production plants, then the atomic weapons assembly facilities, then the initial stockpile sites. And that's what you see on this particular chart down below. This is a charting of our phase 1 through 3 study sites. For those who may not be aware, when I refer to atomic stockpile sites, when the US started building atomic weapons, they didn't immediately distribute them out to lots and lots of bases, to bomber bases. They concentrated them in a series of Q sites, which were referred to as national stockpile sites. And those were operational from about 1948 to 1955. After 1955, the deployment dramatically expanded as fission and fusion warhead weapons were distributed out to dozens of SAC bases and ICBM fields. But this picture does give you an illustration of the first 3 phases. This is certainly a national, it's a continental US study. That's the restriction here. And one of the reasons for that is we have to have the ability to dial this level of information down quite to a level of detail, time-wise and atomic weapons-wise. We have to know when the work started. We have to know when the work finished. We have to know when the weapons were there, when they were not there. So we'll talk about the level of detail. Okay, so those are the 5 phases that we've gone through, and we've actually completed all that work at this point in time. Let's take a look at the phase 2 chart. I think actually yeah, here we go. Phase 1, again, to kind of give the concept of what we're doing here, I talked about comparing activity at the study sites to baseline numbers, total UAP reports, to see if there's anything different there. But what we're really interested in is to try to dial in and say, was something unique going on or something anomalous going on at the study site? In other words, is Hanford different in terms of the number of UAP sightings, the timing of UAP sightings? Is there anything truly anomalous about Hanford or Oak Ridge or Savannah River? These are all materials production plants. So how do you determine if there's something anomalous? Well, in terms of picking controls, what we did was we attempted to pick controls that would be military bases in the same general geographic region, population centers in the same general geographic region, so that we could look at the number and timing of UAP reports that they were generating. Now, we're not saying that they were seeing the same UFO, as it were. What we're saying is their level of activity. And we specifically picked Air Force bases that were air defense bases, that had radars, that had interceptors. Conceptually, the military bases we picked would have been even more sensitive to UFOs and UFO reporting than the study sites. If anything, you would expect, because they're expected to respond to UFOs. This is a national security issue. They detect them and respond to them. So their propensity for reporting UAPs should be even higher. So this chart just simply gives you a feel for the phase 1 study sites and the control centers that we picked to reference them to look for anomalous levels of activity. Okay, let's go to the next one. Atomic weapons assembly factories. We're talking about the Los Alamos site, which assembled the very first weapons that were used both in testing and warfare. Sandia Base outside Kirtland Air Force Base in Albuquerque, which became the major weapons assembly plant for the late 40s and early 50s, and eventually the Pantex plant outside of Amarillo, Texas, that assumed weapons assembly for Sandia and continues to be a weapons assembly plant. The timing for all of these is different. We had to be able to capture the timing as to when they began work, when they ceased work, when it transferred. And one of the things you'll note as we look at our pattern analysis is it becomes quite interesting that what I would call the second generation plants like Pantex that went online several years after, the first generation plants we found did not gain nearly the same level of activity and attention as the first generation plants. Okay, moving onward. Phase 3, the national stockpile locations, an entirely new set of locations, which quite frankly, most people may not even be aware of or think of if they think of atomic weapons. There are several of them across the United States, all the way from Albuquerque to Louisiana, Texas, up to Tennessee. We studied each of these again separately against a separate set of controls. At this point in time in phase 1 through 3, we're probably up to something like 40 study and control sites that we were collecting data on and dealing with data. You see, it begins to become a pretty deep study fairly quickly. Okay, next slide. And it gets deeper. And Ian begins to create charts that actually my gray cells, Ian knows absolutely what he's doing. And I go, Ian, explain the chart to me. And this it covers our phase 4 and 5 military deployment and aerospace sites. These are locations that we looked at, and these are just some of the locations, by the way. We looked at something like, I think we studied something in the neighborhood of 60 or 70 atomic weapons deployment bases and conventional military bases, because we needed to compare levels of activity at atomic deployment sites versus conventional non-atomic bases, logistics bases, training bases, air defense bases that had no weaponry. So this gets to be very complex. Another reason that you see the pie charts on there is we took the time to actually record when the weapons showed up at each base. So we can, in our study, we can dial down and say, is there anomalous activity at that base? And was it strictly related to the arrival of atomic weapons? Was it occurring before they, is there something unique going on at this location that was or was not related to atomic weapons? Is this level of activity got some continuity? It's kind of like Ryan was talking about the keynote. One of the areas that gets to be really interesting is there continuity over time? That really starts standing out, because if there is continuity over time, it really speaks to a longer term intention, as it were. So we have the ability to massage this data at a really extreme level of study as to what was going on at the military bases, and also the 4 aerospace sites that we looked at were Muroc, which is essentially a high altitude air, high speed base, which became Edwards, White Sands, Vandenberg, and Cape Canaveral, which were both rocket development sites, especially ICBM development sites, and later space launch sites. So if we were to fully populate this map, there would be dots over the place. I think I totaled up something like, we're close to 100 study and control sites in this project that we are looking at, and that we have the data on, and we have the ability to study however we want. We could even do the same thing for signature analysis. As I said, that's just not part of our current activity. Okay, let's go on to the next. So what are our metrics? What is our methodology for analysis? Well, our basic metric is incident counts. How many UAP reports? How many UFO reports? Excuse me if I say UFO. I've been around this subject since about 1964, almost as long as Rich. So I have a tendency to slip into UFO rather than UAP. So we're talking about incident counts at both study and control sites. Our methodology then moves on to pattern analysis, which compares the number of UAP reports by year at both study and control sites, and then looks for correlations, and statistical study. Now, I have to say, our fundamental technique that we're using, and by the way, we have a very expert individual in Robert Peterson in statistical study, who has been working and showing extreme goodwill trying to educate the rest of us in statistical studies. And basically we all go, yep, got it. We follow you, Robert, but like you do it and you explain it, okay? So the one thing I will say is, because of the way we've collected the data and the limitations on the number of reports that we've got at some locations, there are some studies, areas that support statistical analysis and some that don't. There's just not sufficient data at the right time to do it. And Robert is very good about telling us what we can and cannot do, and encouraging us not to overstate anything. It's kind of like his instructions: I'll give you statistical data when it works. When it doesn't, we need to focus on the patterns. Okay, back to the next slide. So, good deal. Now I can actually start presenting some of our actual pattern analysis. Now, I will say at this point in time, we've largely concluded our pattern analysis on all 5 phases. I won't be showing you all of it here because frankly, it wasn't even done when we prepared this presentation for the conference, but we have pretty much concluded that at the moment, and we're right at the cusp of moving on from pattern analysis to true indications, intentions analysis. But so, and we have, I will say without disclosing it, because we're saving that for the paper that we're working on. Peter mentioned that. We want to give you an overview of what we're doing, but we also want to write the paper and have it peer reviewed before we give you all of our findings. We have identified something like 10 anomalous patterns related to these 5 areas of study that we'll be reporting on. Okay, so as an illustration, what did we find going on with phase 1? What did we find going on with the atomic materials production facilities? These are the big plants: Hanford, Oak Ridge, Savannah River, that enrich atomic materials to weapons grade, that deal with particular radioactives like plutonium or tritium that are used in different types of bombs, or in fusion bombs rather than fission bombs. And so here's what we found when we looked at the levels of activity. And I guess the basic way to present this is what you see in yellow, or crosshatched or dotted yellow, represents the levels of activity we see at the atomic plants. The gray represents our controls. And one of the things that just jumps out at you, you don't need statistics at all to show it to you, is it appears there's something anomalous going on at the atomic material sites in the years immediately before they began production and when they began production. And interestingly enough, there's this window, is an extreme window that starts occurring through 48, 49, 50, 51, which is not one of the traditional flat or wave years that we think of in UFO studies. It's not 1947, it's not 1952, but the level of activity at the atomic plants is extremely anomalous during that period that we have highlighted as 48 to 51. In 52, the entire world of UFO reporting surged up, and they went with it, but interestingly, not as much. And it illustrates that the atomic plants are kind of having their own reporting life cycle. They're not tied to the standard waves of UFO reporting. They're not tied to newspaper coverage. The other interesting thing that it points out is that once that activity peaked, and we have this burst over 2 or 3 years, it never happens again. From 1953 onwards, there is just no further level of UFO activity to speak of at the atomic materials production facilities. Even when there's just a little peak there when Savannah River comes on in 1953, 1954, but it's over. So it's interesting in that we have continuity for 3 or 4 years, and then the continuity goes away, which is at least suggestive of the fact that the intention and focus changed. Okay, let's go to the next slide. I like this. Ian, even like he's got more colors on this. This has got to be good. Which here we're looking at pattern analysis for the entire atomic warfare complex in phase 1 through 3. The material sites, the weapon sites, the stockpile sites. And again, what you can see is that our windows maintain itself. The activity at all the complex sites has a specific window where it is very anomalous, not only from the control areas, not only from the overall baseline of UFO reporting, but it's anomalous in time, and that it just doesn't happen again. And you can read this, some of the conclusions, some activity, but the windows stand out. And that's one of the things that clearly stood out to us is there's a pattern in terms of timing, and there are windows of timing where activity and apparently interest changes. Okay, let's go on. And we can even get more detailed. I mean, if you want detail, we can do detail. Just put in your reservation, and Ian will cut this down to like day and hour, and we can really slice the base any way we want it. This is just an example of the level that we can go to. We can take it down by month and see if there are sub patterns. And interestingly enough, there are some sub patterns if you get to looking at, and this is just phase 1 through 3. But one of the things that is important about this chart is this chart also contains the baseline. If you look down below, our basic database, as I said, consisted of the Sparks Blue Book unidentified list of something like 2,200 reports, NICAP reports added to that. And what you see is what's happening in these windows at the atomic warfare complex is largely different, other than like a year like 1952, where everybody has seen UFOs. The level of reports of UFOs continues. The unidentified level continues. And if we were to show you the actual total Blue Book report, they continue over time. So when we say it's unusual and that the incident level at the atomic warfare complex drops off dramatically after 1952, that's in contrast to the level of UFO reporting in general that maintains itself at a relatively high level. So it's not that just everybody stopped seeing UFOs, it's just that the level of incidents at these plants and facilities is significantly different than the baseline. Okay, let's go on. Now statistical analysis. And, if you were here, I would refer to Robert and I'd surrender. But bottom line is, in doing the analysis, as I said earlier, for those of you who are familiar with the number, with Kramer's V, basically what Robert has done is to try to chart it out, show you our actual analysis and his evaluation of where the differential is significant. And he might quarrel with the use of the word significant, but the point is, where are the locations where we could truly have some level of confidence statistically that something extremely anomalous is going on with the study sites versus the control sites? And certainly you can say that for what happened at Hanford, you can say it for what happened at Oak Ridge, and you can say it for what happened at Los Alamos, and you have a modest level of confidence that what happened at Sandia Base in Albuquerque is also statistically significant. Now, what we have here are only the first 3 phases. We're still in progress to see what we can and cannot do with statistical analysis in regard to the deployment of the atomic weapons and what was happening at the aerospace facilities. Okay, let's go on. Somebody might ask me a statistical question and I'd have to punt, so I need to distract you. Okay, this is really important, I think, and significant. It's kind of like what Robert was saying. Some of the charts really jump out on the characteristics study. Some of the charts really jump out here. This is a yearly comparison between UAP activity at atomic and non-atomic military facilities. And I have to say, who've written a book about it, just like everybody else, I think gained the impression that, all of the activity was going on around SAC bases or missile bases. There's a real focus on atomic weapons deployment. The answer to that appears to be there was a real focus and a real level of anomalous activity around the development sites, the early material sites, the assembly sites, the stockpile sites. But once the weapons began to be taken out to SAC bases, dozens and dozens of SAC bases around the country. We are not seeing that level of differentiation. We're seeing just about as much UAP activity at conventional military bases as we are at atomic bases, which I consider really interesting and probably indicative. We'll get into that later. There are a couple of exceptions, and that's where we see a real surge, not real surge, but a real differentiation at two particular points in time, which are interesting, which we could correlate to significant events in weapons development. There's that second little burst of activity there that you see in the early 60s, where, yeah, we have more activity and specifically activity going on at ICBM bases. When we start deploying fusion hydrogen warheads on ICBM missiles, the level of activity goes up. Then again, interestingly enough, in the 73 to 75 timeframe, it looks, if we had more data, this would probably be much more significant, but we're talking about this is a period where you only learn what was going on from those people that had the guts to do FOIAs and get information out of the government that the government would not routinely provide. But there does look like there's something anomalous going on there. And most interestingly enough, it has not to do with all ICBM bases, but in particular, the ICM bases that were deploying the first multiple targeted reentry vehicles, the Minuteman IIIs. This may mean something. And on this chart, I've also asked Ian to add, again, what we're looking at down below are some of the baseline numbers from the Sparks database, basically, unidentified objects versus the total UFO reports going to Blue Book. And again, this gives you a feeling for what we're seeing at the atomic complex is not matching the total reporting. So it's not like people in the military were, tied into news reports and the media. The levels are distinctly different. So this gives us some confidence that what we're seeing going on in the atomic weapons complex is real. And if sightings drop off there, the sightings stay low there, that's real because it means that, everybody just didn't get tired and stop reporting UFOs. Okay, I think we can go to the next slide. And again, this is more to give you an illustration of what we can do to kind of close out this discussion, to give you a picture of our pattern analysis. As I said, we have the ability to actually cut this data at a base, a facility level. If we want to study what's going on with UAP activity at atomic bases, at SAC bases, at the Navy bases that house the warheads for the missile subs and the super carriers, we can do that. We can cut it by location. We can cut it by time. We can even demonstrate what's happening there before the atomic weapons arrived. And that's why some of the installations like Davis-Monthan appear really interesting, because it has a high level of activity before the nuclear weapons arrive and after the nuclear weapons arrive. And then once Davis-Monthan no longer has nuclear weapons, it moves somewhere else. But all of this is going to go into our analysis. This is more to illustrate for you and for anyone who might be interested, the level of detail that we can do with this database. And by the way, I don't think I mentioned it. Our database, after refining and filtering our database here, our general database that we're working against is just under 2,000 reports, 1960 reports. The number of reports that we actually pulled in regard to the study sites is just under 600 at 595. But I will say again, tremendous work has been done on the database. We hope to make it available to other people. And as I say, there's a lot we didn't discuss here. It includes a lot of physical characteristics, electromagnetic, radar, colors, a lot of signature information. So I guess I will sum it up and leave it at that, and we'll see what questions come up later. Rich, I tried to be brief, but you know me.
Okay, let me check something. The evening was supposed to be ending right now. Do we want to go into any kind of questions, or do we want to just end it? I think the purpose here was to largely be able to present you an idea of the projects that we are trying to attempt to deal with. I can take a few questions. We can try to go with that. I just don't know your energy level, and you know, my wife will be happy to tell you that I could probably go all night. So all right. Well, I'll take a few here. All right. Why are we spending time on defunct models like 5D, Kaluza, Klein? It does not account for the weak and strong nuclear forces. It was a great idea in 1922. This is 2022, doesn't work. You likely need 10 to 11 dimensions to unite all forces. Similarly, why do we still refer to Alcubierre, who was wrong when Davis in this room and hasn't solved it, I guess, or something of that.
Okay, well, I guess that's me, right? Well, the first thing is the Kaluza-Klein type theory. It's just like Newton's theory is an incomplete, it's incomplete as far as the general relativity goes. But with Newton's theory, you can still go to, you don't need relativity for very high gravitational fields at very high speeds, those kind of things. It still works. In fact, 95% of all analysis and engineering that goes on is all Newtonian based. There's only a few areas. So the idea is that the 5D, although it doesn't, it was given up, when it couldn't be applied to quantum mechanics, and how the atoms, the strong and weak force, it's still, it may be valid. It's worth trying. It could very well be valid in the narrow sense of, as far as propulsion goes. It may not be complete, but it may work, and so it's worth investigating. And our expert on this, Dr. Detlef Hoyer, is an expert on this. He's really gone into this, and so we're gonna see how that would apply and how it would fit to the signatures that these devices create. The other question was, why?
Alcubierre, right?
Yeah. This is a difficult thing to explain, but I mean, there's been many extensions of that. I didn't mean just Alcubierre, but the four-dimensional general relativity in itself. And there's a lot of work going on in that currently the problems are with negative mass and those kind of things. But a lot have been, you change the metrics and you get different solutions. So these may also explain. In fact, I think that some kind of space warping, however that's done, would explain a lot of how these things operate. So that's kind of why we're pursuing that.
Lots of people wake up at around 3 a.m. Isn't that a good explanation for your peak?
I guess I'd have to see a study on how many people wake up at 3 a.m. and go outside.
Yeah, exactly. me too.
I usually just go to the restroom.
It's funny, but in the MUFON database, if you looked at cases we always got, and this is everybody that's been in MUFON will attest to this, you get cases and they always start off with, I went out to walk my dog and smoke a cigarette. And that's when they saw it, right? Because that's what the reason was. They were outside, they had nothing to do but look up, right? So there you go. Couldn't the lack of triangles during the daytime be due simply to an inability to resolve sharp edges in a bright daytime sky?
Not sure I follow that question.
I think I can.
Okay, go for it.
Let me share with you. Remember I mentioned the Hynek report that I viewed in that engineers club? They talked about the fact, and they actually had an example on the screen. The vast majority of us, it's easier for humans to see and perceive an object that it's a dark sky that's light. In a daytime sky, when we're outside, you may have aircraft going over, you never see them because it's a dark object on a light sky, okay? So more people will tend to report a lot of times at night because it's easier for you to see a light. How many, I mean, there's been tests on this, but you go out and see the planet Venus or the planet Jupiter or something like that stationary. Oh my God, there's a UFO up there or something like that, right? But your attention is captured that way. Go ahead.
The only thing I'll just mention is we're not really talking about lights at night. We're talking about an object that's roughly a third or larger the size of the full moon. And normally the triangle is a dark object in the daytime sky. So I would think you would see it, but maybe not.
Why isn't Congress interested in your nuke intentions study? They should be. Well, I agree with that. I don't think that it's done yet. That would be the answer for that, right? Larry?
Just have to ask. We'll be happy to share.
We'll be notifying them soon.
Why were there no error bars in your plots?
Well,
There were no error bars in my plots because I just did this for you guys. There will be when I put out a paper on it. So that's why there's no error bars in it.
You could show a statistical significance for UAP around nuclear missile silos. But how do you account for the systematic error caused by the fact that more people are watching the sky near silos? How can one possibly account for that?
Well, we have not done the statistical study for that phase yet. So I can't at this point say that we have positive or negative statistics or a correlation at all. As far as watching the skies, what you can say is, remember, we for comparison purposes, we're comparing military bases that have atomic weapons to military bases that don't, conventional military bases. All of those military bases have security forces. Most of them are under air defense, certainly during the Cold War. We're under a proactive surveillance radar defense with interceptor coverage. So especially in regard to these types of military bases, there's no particular reason to think, for example, that a SAC base that only had bombers and no ICBMs would be any less sensitive to UFO reports than an ICBM base that has, 50 silos scattered over 1,000 square miles. About the best way I can answer that. And a security force of maybe 50 people to deal with that 1,000 to 2,000 mile security reservation.
What additional information do you have that might account for the spike in reported sightings during the time frames from 1948 to 51, 65 to 68, and 1975 at nuclear facilities? For example, military conflicts like the Korean War creating a heightened sense of alert at a base could account for the spikes in those years.
Well, I think in terms of pattern analysis, we haven't got to answer that question yet. It's sort of like, yes, was the UAP activity triggered by significant events, related to significant events? As I mentioned, we have actually created a significant event table that contains entries, contains entries for things like air defense exercises, continental air defense exercises, SAC airborne alert exercises. It goes all the way down to media and entertainment activities. And as we move into the intentions analysis, we'll be plotting all of our charts against those significant events to see if we find any correlations there. So the real answer to the question is we're not there yet. We intend to be there.
Also, the answer to this is probably the fact that we aren't looking at Africa. But anyway, what about uranium extraction sites like Africa and other countries?
It is possible. One of the domains that we have talked about looking, I mean, there are lots of domains that you can look in. Geophysical domains, resource domains, which would include resources. We could look at that. I will say, based on an earlier presentation of this material inside SCU, we received a question as to whether or not, how does this correlate with what you see at commercial power plants, atomic power plants. We have gone back to take a look at that. We're still in the process of finalizing that study. I will say, based on what we have found, although there are some largely uninvestigated reports of incidents at atomic power plants, we're not finding anywhere near the same level of anomalous activity. Actually, we're not finding any anomalous activity at all. We're just finding periodic anecdotal reports and absolutely finding no patterns. So about all I could say. I can't say anything about natural resources at this point. Could be. I'd probably have to start in the US and Canada, where we know where the major geographic uranium deposits were, that sort of thing, so that we could correlate to that, to our study database. But at this point in time, it doesn't appear that I could say that there's a level of anomalous activity at conventional atomic power plants that's anywhere like what we're seeing in the atomic warfare complex.
Will the clean data sets used to generate these reports be available for public review?
I would think
Yes,
so.
they will be available for public review.
All of our research will eventually be public.
Actually, that
open
was one
source.
of the things I was commenting on. I hope at some point in time we can take the databases that we built, and Robert knows our characteristics database had a lot of signature information. I hope people will come and want to use it.
Does SCU have a separate team of people that have security clearances that analyze classified data? We have people that have classified clearances. I have one, but we don't have data. Yeah, and we don't have a SCIF.
Yeah.
So ultimately, the answer is no. You need to do that behind a SCIF to be able to do that, and we do not have that. But again, there are people like myself that do have security clearances that are in SCU. All right. Recently, a U.S. representative said that their briefing, that if the general public had heard the briefing, the public would be panicked. If what this political representative said is true, what is implied? A worldly takeover, humans as a food source? Or they will soon take our star away and leave us to develop a different source of light, heat, and climate change?
Yes.
Rich, could I comment on that one?
Yeah, please do, Larry. Take that on, would you?
Yeah, since I'm remote, it might be safer.
Yeah,
what
you
I was
are.
going to say, my guess would actually be to follow on to Peter's remark. Considering how much discussion there was during the open hearing of the drone swarm over the Navy ships off San Diego, my guess is one of the things that went on the confidential hearing was there was a lot more dialogue about drones and the lack of the ability to track drones and deal with drones. And you yourself know, drones are a big issue, and I suspect the dialogue that's scary may not have been about UFOs or aliens. It may well have been about how exposed we are to drone swarms.
Is the SU studying any USO events? Any suggestions on how the private sector can start amassing data and studying the phenomena underwater?
I guess I could comment on that. We actually have a USO project that's kind of in a state of being reformed somewhat. we want to go back. Dr. Little is the driver of this project, and she would like to go back and kind of re-look at our database. And we did spend a lot of time, and we actually had output on it, but she would like us to go back and redo that output. So I guess as a teaser, I could tell you an output that showed up, but when we go back and redo it, maybe this will disappear. But the two most prominent areas were Catalina Island and Puerto Rico.
So the short answer is yes.
I don't know if you're aware of it, but some people have shown me the video clip. But there was over, I guess, London yesterday. There was an object that was moving along, and basically it says, "Could you take a look at the objects filmed over London yesterday? Seem very similar to Aguadilla, Puerto Rico case." I don't know that that's the case, but anyway, details are posted in the community section. Are you guys aware of that object? This was the Queen's Jubilee, I guess the parade. There was something that was going on, and there was an object that went across the screen.
I saw an image of it. It's kind of hard to tell, on a cell phone to know exactly.
They came to see the Queen, obviously.
Well, right. They were watching that whole event and part of the parade, actually. I don't know that we will. I mean, it's certainly not like the Aguadilla case where you had a whole lot of metadata and things you could actually look at. This was just a video clip from a news clip that saw an object that was moving across the sky. But anyway, for Robert, have you looked for patterns in the observers themselves in addition to their reported sightings?
Okay, so I assume they mean by looking for patterns in the observers themselves. Actually, that's kind of a good question. The type of data that we pulled out, I don't think that would work, but you could do something along those lines. I think someone else mentioned it earlier. If you want to look for patterns in observers themselves, you really need a team that's geared towards that. So
yeah, I mean, that would be a psychological project. I mean, that would be, we talked about not just doing physics, but there's a room here for psychologists and many other type of studies.
It would be a massive project.
Yeah.
I mean, to do that properly would take a lot of work, and you'd need to be in that field.
This question comes in, and I think I can also play a part of addressing that. I was asked this on a History Channel show that you'll be seeing probably in the fall. But the people are correlating and wanting to correlate, like, for example, in New Zealand or something of that nature, where you have a lot of seismic activity and maybe because of the ring of fire that goes around the Pacific, they might have a lot of cases in their specific geographic location. So to them, they draw in their mind a relationship between seismic events or volcanic activity, and they want to say that that's where UFOs are and that there's a correlation. The question here is, I've read reports of increased UAP activity during seismic events. I know that I've got an app or something like that I can look at. There's like about 100 events going on every day. So, I mean, but any of you seen any? I've never seen any published studies of anything that showed a statistical correlation between UAP activity and seismic events. Correct?
There's some, studies that have been done about piezoelectricity development, where you take a crystal and you bend it and it produces like, balls of light and that kind of stuff. So, but we're not doing anything on that. But
I look at that as being the IFOs. There's a lot of IFOs during volcanic, meaning
they get misidentified.
Identified, or something of that nature. But actually ones that are investigated and looked at. Are you familiar with the suggested correlation between those events and UAP? Is that possible relation something the Intentions Project was considered investigating? All right, so let me go to the next question. Very briefly, you might want to take a look at night shift lunches between 1 and 3, apparently in the morning, I guess, or something of that nature, and your circadian rhythm of waking periods. This might give you some also spikes or something of that nature. Robert, isn't it true that this style of saucer-type UFOs have changed significantly over the decades from the 1950s till the present? This would be a pattern change over time?
Okay, that's an interesting question. I can tell you I didn't do a presentation on it because there's a lot of things in the characterization study we've looked at, and I was just trying to give you guys a snapshot. But one of the things that we did characterize is there's basically two types of more common saucer shapes. There was one that's basically 30 to 50 feet in size with a ratio of roughly 2.5 to 3 to 1 in terms of its ratio. Then there's a larger version that's more like 100 to 150 feet, and it's more of a 7 to 1 ratio. When I'm talking about the ratio, I'm just talking about if you have a disc, the ratio of the length of that disc to its width. So we did look at some of those, how could we classify the approximate size and features. There are changes to discs that are different back in the 40s and 50s to the modern day. I would say the most striking one in my mind, how many of you guys have ever seen 1950s science fiction movies? Have you ever seen the saucer that looks like he's about to crash? Okay, that's what witnesses reported, and that's why the movies show this saucer that's moving through the sky like that. In more modern times, I've never seen those type of reports. I won't say never. I saw one report of that in California about 15 years ago from a security guard. And that was one of the things that made me think the security guard was giving me a very valid report, because the security guard was in his 30s. He would not even be aware of that from back in the 50s and the 60s. And he made this very detailed description of how the object looked like a floating leaf as it was moving down towards the ground. And that was common back in the 40s, 50s. So there are changes in the way these objects look. And I'll just conjecturize on something here. I've seen enough of that it makes me wonder whether or not, whatever the origin is, that those are from the same origin because of these type of differences, that you see.
Would it make sense to view UAP as an intelligence gathering and analysis task with science as a subset of that effort? Science would be employed to approach specific problems within the larger effort. I think that's more of a statement as opposed to a question.
Yeah, I'm not sure of the question.
Yeah. I think would it make sense to view UAP as an intelligence gathering and an analysis task with science as a subset? So there is a question in there.
I mean, I can tell you my personal view is that they're intelligently controlled. And that's just based on doing this for 15 years.
How do we know that we're not seeing variability in the reporting modality or context itself rather than the real fluctuation in the incidence of UAPs themselves? How feasible would it be to look for the same kind of patterns for other crucial historical moments? For example, the development of air travel or even the emergence of industrialism.
Well,
Anybody want to tackle that?
I'll just, we have limited resources. We don't have 100 people doing research, so
Correct.
we've had to, zero in on what we can do, and we focused on this one at that time.
It sounds like an interesting subject over a beer.
Well, Larry said he'll be doing that.
I would say in terms of our data, Robert, and we've run into, basically for our database, the modality stayed the same. You had, as far as the Air Force was concerned, you had people that were using relatively standardized collections forms, asking similar questions, not too different than the report forms that you would have found being used by NICAP or even APRO back during the same period. I used similar forms for APRO myself. So the collections tools, the questions that were being asked, were very much the same over the period that we're studying, for example. Now, how the people are responding, how the individual investigators are asking the questions, you could talk about, but as far as the collections devices themselves and the information that's being gathered was pretty consistent.
You know, what I've found in general is the most critical part is really the follow-up investigation. I mean, even with a standardized form, if you don't have an investigator who knows how to ask the right questions and to draw out the information they need for what happened in a particular case, I think a standardized form is very important, but it does not, it's not the final answer for what you need.
This is going to be the last question. Is it possible to definitively prove something is not prosaic given only a video or a picture? Or do other sensors need to be involved in order to make sure you have the whole picture?
Oh, if you can, say have a video and show that, let's say, its trajectory or its acceleration is beyond anything that current technology can achieve, then you've shown some things anomalous. The power requirements to do it, if you consume a certain mass, whatever. So you could determine some things as being anomalous, and that itself, is worth more investigation. But obviously, the more data you have, the more you can do, and so the more different kinds of sensors you have is going to improve what we can do. And that's what, like with UAPX and some of our other ideas, we're trying to expand this. One thing could be like, if it's gravitational power, it should affect time synchronization. There's going to be time dilation. As the gravitational field gets close to the object, the clocks are going to change. Or and there could be some kind of radiation or those kind of things. All that is possible, to study, but we're not there yet.
All right, gentlemen, thank you.